Which one? Thank you for bringing a question to the table. Catch. Good catch. That was a great throw. It landed in your hand. It literally landed in your hand.
It bounced on the table.
Regardless, ask a question, get a Kit Kat. Don't ask a question, don't get a Kit Kat. We're talking about 9. Talking about the domain of a composite function. We're talking 3 things you have to remember for a domain of a composite function. 2 are like checks, and 1's like a nope, don't worry about it. If you're talking domain of a composite, there's 3 things to remember. 2 are checks, and then 1 is don't check, but it's worth knowing that you don't have to check it. So, anybody got any of those that they remember from back in the day? What do you check?
G of X.
You check the not G of X, but yeah, the domain of G of X. Domain of the whole entire thing, which is f of G of X. And then it's worth noting that you don't check f of X. It's just worth racking your brain and remembering that so you don't accidentally do it somewhere along the process. Okay? So let's go ahead and do A. I guess before even solving it, it's worth knowing, do we know how to write f of G of X for the A one? Yes is not an answer to the question. What goes on the inside? That's going on the inside, right? And G of X in this case is that blue cloud, right? So that blue thing is going to be root X. And then what goes on the outside of that whole thing? 2 box plus 1, if you like looking at it that way. If you don't, it's okay. You don't have to. That's just the way I look at it. Where this is the red stuff. Okay. So if you want to clean it up a little bit, you could do 2 root X plus 1. Now it's looking like a normal function. And we got to know what to check. So what are we checking first? I think I'm checking G of X first because that's the first thing you said. So what is the domain of G of X? Just 3 completely separate, actually 2. 2 completely separate problems that we're going to mash together. What is the domain of G of X? You got it without even thinking about it? Go for it. What you got?
So it's, do you want to?
Yeah, no, send it to me because we've done it a bunch of times.
So 0 to infinity.
And that's it?
Yes.
Cool. If you don't like that, rack your brain back to yesterday. I'll scroll up a little bit. And you can go watch the video if you want to, or you can just look at it right here. We did the domain of that. We did the domain of that kind of stuff right there. This one was just a slightly easier one because there's no changes. X is greater than. And if you don't like doing that, you can just think about what it looks like. Where does it start? Starts at 0. Where does it go? Forever. Okay. Now let's talk about the second condition. The domain of 2 root X plus 1. Interesting. That feels a little tougher. But I propose that it's actually not tougher at all.
Actually, would it
It would still be exactly the same thing, and why?
Because it's not. Nothing happens on the inside.
Because nothing happens on the inside that's different, right? And there's no There's no fractions. There's no fractions or X on the bottoms to worry about. So it's just kind of exactly the same. So what do you think your total domain is? Just that, right? It's not too bad to solve. Cool. You don't have to check f of x. Mm-hmm. Why does it start at 0? It starts at 0 because when you ask yourself, I don't even care, go over here. I don't care what on earth the equation is. When you see the word domain, you think two things. What are those two things? Number over 0 and negative square root. Hop back down there. Is there any way for it to be a number over 0 at all? Not even possible. There's no x on the bottom, right? There's no fraction at all, much less x on the bottom. So we don't even have to worry about that one. So that one was good. But then we have to ask ourselves, is there any way for there to be a negative in the bottom? Yes, there is. What would have put a negative under the square root? That would have been if we took everything under the square root, which is just x, right? And said that x has to be bigger than or equal to 0. It has to. I mean, if you don't like it, try the 3 points around it. Try -1. You're going to get an imaginary number. Try 0. You're going to be fine. Try 1. You're going to be fine. So it's kind of this idea right there. Boom, boom, boom. 0 of... And this stuff is all bad because of what's underneath, not because there's a square root or not because you got a 2 and a 1 on the outside. It has everything and only thing to do with what's underneath, not anything on the outsides. Correct. If we graph this, it would probably be, this is normal, right? It would probably be up 1 and then twice as tall. Well, that was dumb. Hang on. Twice as tall. So what is the domain? This was +1, and this was times 2. What is the domain of that green function? That matters that you know what letter domain goes with. So does domain go with x or y? Domain only goes with x. So you draw your little line, and you start working your way over, and you say, where does a green line start? Right there. That's where it starts. It starts at 0. And how far does the green line go? Forever, never, and ever, infinity. And then you just close it up by saying it includes 0. It don't include infinity. You're not looking at y. What your brain did for a second because of the +1 was thought about y's, and that would change the range. That +1 would change the range from 0 to infinity to 1 to infinity. But it didn't ask us about range. That other problem we did the other day did ask us about range, and we did it. But this specific one didn't ask about range at all. So, all right. Save that. As we're saving it, as we go, it's updating on the website if you want to check. This morning or last night, I don't remember, I posted the completed notes, the video, and the blank review across the board on the regular lecture notes website. So if you want to go look for that, you can. Sure. I'm out of Kit Kats, though, so. 3? Yeah, but I'm going to take 3 and make it even one step harder, just for the fun of it. So, and you can still go home and practice 3, and practice all 3 of them. But I'm going to take it and make it one step harder so that it looks a little more like what we might be seeing, just so you know. Just so you're not surprised. So, excuse me. Anybody have any thought of how they might make it one step harder? What? Cut out the slope and but they would have to give you something instead of the slope. 2 points. Yeah, that's just like one step harder than this. So I would think one step harder would be no slope and another point, which is totally allowed. It's not even going to be that much harder. It's just one more step. And make up a point. Someone make up a point.
-2.
Someone else. Cool. That's so similar to our first point. Oh, so that's our second point. This is point 2. Somebody make up another point. 0.1. I don't know why I did that. I don't know why I started with 2. 0.1. 0.2. Someone make up another point.
5.
Thank you. Don't you say it. Don't you say it. I know you were. That's exactly what I thought you were going to say. I'm picking the number 13.
13. God.
It's prime. It's tough. Friday the 13th, all that stuff. This Friday's Friday the 13th. In October. Ooh.
No.
What? Spooky. All right. So now what do we do to find? Because this is a little bit harder. So what are we going to do here? Formula. Y2 minus. Yeah, I'm just giving you a harder problem because this is more like what it's going to look like. Same. We are going to run into this problem halfway through. We're going to run into the same problem halfway through what we're doing. So which one's Y2? What do we got to label them? X1, Y1. Dang it. I'm very bad at keeping things straight like that. There we go. Boom. X1, Y1. So we're looking at 13 minus 5 over 5 minus negative 2, which is 8 over 3. Sorry. 7. And what should I put right here so my brain doesn't forget? Yeah, good call. I like that. Boom, 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 boom. Just so you don't forget what you did. I like that a lot. And now you're sitting looking at the same problem you just asked us to do. We have a slope and we have a point. Find the line. But I just wanted to do the one-step harder problem. So let's do this now. We have which point do we want to use? It really doesn't matter. Just use one. Who cares? So how do we plug it in? Plug and chug. Y minus. No, not y equals x plus b. Not possible. Because these aren't y-intercepts. The point slope form. Y minus 5 equals x minus negative 2. And you got to just do a little manipulation, a little moving stuff around. And then you got to move that 5 over.
Y equals 8 over 7x
plus 35 plus 16.
Which is going to be 51 over 7.
Remember this thing right here where you go like that? Whoa, not like that. Remember this thing where you go like this? And you go times plus?
Yeah.
So it's 35 plus 16 is 51.
I said it.
Good job.
It was two numbers away from being divisible.
That's not too much work. That is a normal problem that could happen. The fractions are allowed. The fractions are so allowed.
That was two numbers away from being.
2-digit addition is on the table. I'm sorry you're in college. Like, 7 times 5 ain't hard. The 7 times 5 part ain't hard. So that's 1-digit multiplication on the table. 2-digit addition also on the table.
Sorry, this wasn't to your liking.
Now, simplifying, that is harder. We're not asking you to do that. We're just asking you to solve.
She was saying that if you just plug in 2 for x and you can solve for b.
Yeah, what I did was I plugged in 5 for y, I plugged in negative 2 for x.
And you plugged in 0 for y. No.
No. And I solved for b, and that's all I did.
How'd you solve for b?
Because that'll give me the y-intercept to find the line.
How'd you do?
5 is equal to y. So I'll do 5 equal 8 over 7, and then negative 2 is x.
Did you get the same answer?
Yeah.
Okay, good. I don't know what you did, though. I'm listening. Show me what you did. Show me your paper.
I did a different question.
Then it's not the same.
Yeah, it is.
Yeah, I just already explained.
I trust you. I trust you. All right, what else we got? What else we got up here? Yeah, one's pretty tough. One C. Oh, I should have copied it. Dang it. That's my fault. All right, one is the toughest one. We've talked about this already. One is definitely the toughest one. Gosh, I can't take it because it's got all that stuff in the way.
Can't you technically move it?
Yeah, but all this stuff?
Yeah.
Oh, and by that you mean erase it?
No, but so I mean, like, you can just highlight it, then
Move it, copy, move it back. But it's circling.
Or, just you can you can circle it again.
Nope.
No, but what I mean is you could just circle all of it.
Delete it.
No, move it away, drag it away.
I have a better idea. Watch this. Hey. Now watch this. That was pretty smart. That's pretty slick. All right. What are we doing?
More complicated.
Yeah. We're doing C. Okay, this is the toughest type. I agree this is the toughest type because we have to know how to FOIL, we have to know how to factor, we have to know how to combine like terms, and we have to keep straight a negative distribution. So there's a bunch of things that happen in here that are tough. But if you just do it one color at a time, I think life gets better. So I'm even going to take it one step slower this time. F of x plus h. You don't know anything else. What's the only thing that you should be able to tell me about this right here? What are you going to do?
You can know F of X.
Nope, you don't know f of x. I'm telling you, if you just saw this on the screen alone, you should only be able to tell me one thing that we're doing. Plug it. Don't say it, because it. Plug what in? No.
X
plus E.
Yes. Just like if I would have showed you this and said zoomed in, what do you do? And you all would have said plug 3 in. When you see this, all the our brain should think is plug x plus h, as ugly as that is, in. Okay, so let's plug it in. So plug it into the first one, and we get
X squared
x plus h squared. Careful.
minus
5 times.
4. Wait, are you doing A or C?
I'm doing C. Oh,
Yeah, because they're this. Yeah,
I'm doing C.
Okay.
It's going to be the same type of problem.
Okay, so then you can just distribute the
Okay.
distribute. Do you want to distribute
Yeah.
So that'll be
X squared
plus 2xh plus h squared
minus
5x plus minus 5h minus 1.
any like terms that combine.
No.
This was a FOIL. This was a distributive property. And the negative one was just alone. If you're wondering where that happened. Now let's do the blue thing.
Minus.
I'm not even going to do minus yet. I'm just going to do the blue thing. What is f of x?
X squared minus 5x minus 1.
Now what am I going to do with that red thing and that blue thing?
Subtract.
So big old parentheses. Minus. What are you laughing? Hey. We could just take the test tomorrow, if you'd prefer.
So then you did.
And then everybody would be mad at you.
And then
Why are you not supposed to do that 1v1?
Yeah, that's tomorrow.
Oh.
Distribute the minus sign.
yes, so it basically turns to negative x squared plus 5x plus 1.
Minus, plus, plus, plus. Anything cancel?
The x squares, the 5x, the 1.
If that doesn't happen, go back and start over. When you get one of these problems, that's going to happen. So if it doesn't happen and you don't feel almost everything in that other term cancel, go back and start over and re-look at stuff or just start fresh because that should happen pretty much every time. But we're still forgetting one little thing
So
that was in the original problem. A green H on the bottom, So do the whole thing over h, and let's just write it a little bit prettier down here.
So yeah.
2xh.
Plus h squared minus 5h over h.
Oh, shoot.
What if the h's keep?
They can cancel.
So you lose till 2x, h will just be 2x.
If you want to see the prettier way to know why they cancel, watch this.
Factor out an a.
Yep. I've been struggling with how to teach this well because sometimes people are like, it does cancel. Sometimes people are like, it doesn't cancel. And it's hard to know when it cancels, when it doesn't. So if you factor out that h,
You're left with
h times
2x plus h minus 5 over h.
and what's the opposite of multiplication, which is right there? Division. So they do cancel out. But division isn't the opposite of addition. So you got to be really careful. If you don't have it in every term, you can't do it. If you do have it in every term, you're more than likely going to be able to.
So then you're left with 2x plus h minus 5.
2x plus h minus 5. Boom, 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 boom. And when you get into Calculus 1, which I know might be far away, but maybe not. When you get into Calculus 1, that is one of the most important formulas you'll ever see to get started in this world of calculus that we do. So next fall, you'll be in Cal 1, and you'll be using that equation all the time. All right? That's ugly, but also really cool that it simplified so well. And watch this. I don't even know number 1, but I could probably tell you, is it something like, did we do number 1 already? Or A? Is it something like 2x minus 4, maybe plus h? Something like that. When you get into Cal 1, your brain is going to be able to do them pretty darn fast. This one's probably going to be something like 8x plus h. Anybody do it already as homework? Oh, is it 4h? Thank you. But oh, you did it as homework? Dang. I don't have any Kit Kats for you, but thank you. I'll get you one later tomorrow. Yeah, I brought it for the first question. Yeah. Yeah. The formula that tells you what the slope is at any given point is what that means. So, yeah, there's this thing that this thing matters a lot, but it gets easier. All right, what else we got? Any other questions? As we have a lot of time left. We can also hop out of the review and into the end of chapter assessments to look for some stuff too, and I might do that after this. 7B. Ooh, I'm just gonna do it up here. No, I'm not. That would ruin this system we've got going. Basically, this is just can we piece together what transforms are happening to it, and I don't mind if you do them both at the same time or separately. I'll see what you're doing when you work on it on Friday. So what two transforms are happening? This one is to the right one, and this one is vert flip. Okay. Does it matter which one we do first for these two? It doesn't, I don't think, right? Okay, so I'll do the blue one first. No. Yeah, I'll do the blue one first. To the right one. Oh, I don't want to do this. Just be careful. Take each point and go over. Take each nice, neat point and just go over with it. One. And then you should be able to connect the dots. And it's okay if the not nice, these points aren't perfect. Yeah, I was going to do them in two phases. You're allowed, if you show me the 2 phases of or 3 phases of your transform, I'll see what you did and be like, oh, cool, that's the last one. So I'm totally okay with it. So that's the right one phase. And then we got to flip it. So that's normal. Flip across the x-axis, flip across the x-axis. 4 down. 1, 2, 3, 4, 1, 2, 3, 4, 4 down. So it should look something like that probably. Yeah? You cool with that? It's not too crazy at all. I want to throw y'all a curveball now. Table of contents. What chapters have we learned? I know I should know, but I forgot. What is this test over? All of 3? And one section of 4? Yeah, because we're not doing 4. Yeah, 4 is short, and we're not doing 4-2 or 4-3. We just did 4-1. So that's nice. Practice test. Let's go look here. Throw y'all a little curveball. Which of these look tough? These look pretty similar to what we're doing right now. Ooh, this is one that didn't end up on the review, but is actually fair game. And I don't know why it didn't end up on the review. This graph right there. Okay, I'm going to do both of these. Let me zoom out a little. And if you want to go look at this review, it's totally in the back of the book. Or not at the back of the book, but in the chapter we're working on in the book. This practice test. All right, let's do this. This is fun. This will still be online too, so you can just open up the review as well to see this problem. The increasing, decreasing thing. Was that on the last test we took?
No.
I didn't think it was. I just pre-cal this class I get mixed up sometimes. So that idea of where is it increasing, where is it decreasing? Increasing, I usually do in green. Where is this function increasing at? What does increasing look like? Going up. And what does decreasing look like? Going down. So now our job is just to go find those spots. So where does it look like it's going up? Right here. And tell me when to stop going up. Tell me when it stops going up.
Stop.
And now switch to red. Tell me when to stop.
Stop.
Yep, you got it. This is how we do this. This is how I do this. Green. When does it stop going up? Never. All right. So we have 3. We have 3 different spots. Well, these are actually arrows, so don't do that. So what is the green interval? This is going back to that domain question. What is the green interval? To cool. And what is the red interval? Cool. And what is the green interval? Whoa, where'd it go?
You deleted it.
I don't remember that. That one is 1 to infinity?
Yeah.
Okay. I know it's kind of an easy thought. We didn't spend a ton of time on it in class, but it... What? You couldn't put open? Oh. You can use either on the test. And on the test, on the question in parentheses, it says use either because I've seen 2 different textbooks that say 2 different things. The math world, it's like, is it on the interval? Is it not? I don't know. It's not technically increasing or decreasing there. That's the max or min. So do you include it or not? Who cares? Approximate the local max. Express it as an ordered pair. So where is there a max? Negative 1, 1. And where is there a... Oops. That one says min. There's a max at negative 1, 1 and a min at 1, negative 1. Cool. Not a hard type of problem, but a fair game one that I guess I just didn't make it to the review. Let's go see if there's any other. Inverts. Did we have any inverses? Yeah, this entire table looking thing is pretty fair. But I think it's part of what we've been doing. It's just a little different way of looking at the same types of questions. Like f of x, like look at that first one. That's the same question we've been doing. It's just in a table instead of in a function. What's f of 6? I know it's not on your paper, so you can just look up here. You're saying that f of 6 is 13? Where'd you look for that? Right there? Any questions on that type of thing? I can zoom in more, sorry. I know it's far away. What about where is f of x equal to 5. Now we got two little spots we could look at, right? Is it this one or is it this one? And I'm feeling like it's this one because it's saying when x is 2, y is 5, right? So at x equals 2. Or if you just wanted to write f of 2 equals 5, that'd be a perfect answer. Increasing or decreasing? Well, it goes from 1 to 3 to 5 to 7 to 9 to 11 to 13 to 15 to 17. So it looks like increasing, right? Ooh, is it 1 to 1? Huh. What does 1 to 1 mean?
Each output has one. Each input has one output.
Input? Each input, one output. That's a function. That's the definition of a function, right? What you just said, I know it's hard to think about, but what you just said, I think, is the definition of a function, that each input has an output. There's a word you're missing in there.
Repeating?
Yes. Input there's a special word that goes right there. Unique. Output. Cool. And if you don't have the word unique, that's just a function definition. Because if you don't have an output, then you are like, blah. Or if you have two outputs, then you're like, ah. But each one has a unique output, matters a lot. So another way to think about that is kind of like, what's the shorthand way to think of what a function is? This is unrelated, but the shorthand way to think of a function really quickly, like the most quickest way to check if something's a function, is you check for blank, don't blank. X's don't repeat. That is the super fast way to check for a function, right? Okay, you know what the super fast way to check for 1 to 1 is if you're just doing super shorthand? Y's don't repeat. Absolutely. Which is the word unique. That's what the word unique takes care of. So if you want to think of it that way, that's kind of fun too. So do the Y's repeat up there? No, because it's increasing the whole time. So, yes, check. Ooh, they gave us the same exact question as before, but with the ugly little nomenclature. What's the inverse of 15? You can't see. Let's go find it. The inverse of 15 is... Oh, that's nice that they didn't give us the other 15 to be scared with. Like this 15 turns into 30 or something. The inverse of 15, because it means go backwards, right? Switch x and y, is 7. And then 33 has nothing to do with this equation. It just says, can you find an inverse, which we've already done. That was the whole switch x and y and solve thing. We don't have to do that. I just thought this might be worth doing because we had all of these exact same questions, but with an equation, and this one has a table instead. So, pretty interesting. All right, I'll take a pause from that review. Anybody got any homework questions? Or what's it called? Review questions that we didn't get to yet? What was the hardest homework question we did this set? Like, you know, the ones you were just like getting annoyed with and you never even answered because you just gave up on? What? Oh, like the same types of problems, but just with words?
Like the word, I think one of like the words.
One of them had what?
Oh, because it was one of them talking like bricks.
Bricks? There was a brick problem?
Oh, the brick one.
Oh, well, let's do the brick one and then we'll call it a day. What is, I need to go look at it. But the brick one? Do you remember what section it was from? 4.1? All right, where do you see bricks?
Just like he's moving bricks with a wheelbarrow.
How do I just like preview the whole thing? Teacher preview? That's so annoying. Y'all are so right. All right. I'm going to throw this on the test for extra credit? No, I don't know. Was it just big numbers? Is that what was annoying?
I was just reading.
It was just reading.
Well, grow up. You're in college.
It was like, oh, you put a random amount of bricks down at the start and figure out what that is.
All right. Well, let's do it. We still got 12 minutes. We'll be able to finish this. You have 773. Oh, y'all can't see that. Hang on. This is fun. Thanks for bringing that up. What'd you say? What'd you say? Shh. You have 773. You need to move them all. You buy a wheelbarrow. 4 wheelbarrows each hour. After 5 hours, you've moved that many. After 7 hours, oh, we should just make a table then. Is that like after they give you a certain amount of things? So after 0 hours, how many bricks have you moved? Yeah. After 4 hours, or no, wait.
No, not.
5. 5 hours. 325. 7 hours. Shh. Hey. I'm not doing your homework for you. How many bricks an hour are you moving? Oh, it told you this is slope. So how do you find slope if you've been given this thing right here? Y2 minus Y1, X2 minus X1?
That was the easy part.
Okay. Well, should we do it? Will somebody do that for me? I don't have a calculator. Y'all have calculators? Or do you not? Fine, I'll do it. 453 minus 325. 13 minus 5 is 8. 4, 2, 128. So that'd be 128 over 2. So that's 64. 64. How many bricks had you moved by hand before you started the wheelbarrow? Oh, I didn't even know that was a part of this question.
So you have 773 in total. So I'll do 773 equals 64x plus b.
Oh, is this the rest?
What?
I don't understand how to answer that question. Do you?
Yeah.
773
Yeah, we got 773.
is where you start.
That's the max, so that'll be
Yeah.
5. So equal that to 64x.
But you moved some with your hand.
Yeah. The b will be the what you move your hand with.
Yeah. How do you find that B?
Right, you do. You could have solved it. 773 equals 64x.
Equals
64x
your slope, X,
plus b.
plus however many you moved with your hand.
Yeah.
Oh, that's what I was asking. It doesn't say you finished, though.
Yeah, you did.
Oh,
You just solve for b, and that's how you'll find how much you moved with your hand.
okay.
So you just plug in one of your x's.
Oh, so we shouldn't use 773 then. We should use,
Oh yeah. You should want y. My bad.
I should do whatever. Yeah, that makes more
My bad,
sense.
my bad.
Nope, you're right, though. Y equals that, right?
Yeah, y equals that.
Okay, we're running out of time, so I'm going to do this quickly. Y equals that, and you solve for Y, right? And then the next one's going to be using that B, and just plug and chug. You're done. You know your slope. You know your original. And then is it going to ask you, lastly, how long does it actually take you? Yeah, solve for when it equals 773. Oh, that is intense. That is the whole purpose of a linear equation right there. Yeah, I don't want to do it because I don't have a calculator and it's going to be big fractions, huh? Was it all fractiony?
No, it was actually.
Oh, it worked out nice. Well, here, we got time. Let's do 64 times 5 plus b equals 325. Somebody hit that on a calculator real quick. Divide 325 by 64 times 5. minus 325 minus 64 times 5. It's 5? So B is 5? That is nice and neat. You're right. So then your equation is probably something like 64x plus 5. Oh, so you only move 5 with your hand?
Yeah.
That's so lazy. Like,
Well, you don't know how big the
that's true. But if you move 5 bricks and you're like, oh, this is too hard, I got to get a little barrel. It's like one trip. Okay, and then last but not least, it's probably set equal to 773 equals 64x plus 5. And then solve. So 773 minus 5 divided by 64. It's probably 12 hours. So that is 12 comma 773. That's a fun problem. That's going on the test. What's up? From the beginning? What? As soon as you find your slope, you have 2 points. You could do that and then manipulate. Yeah. As soon as you found your slope, which is pretty early, you have 2 points already. Point slope, manipulate, you'll get your B value. That's your y-intercept without doing the plug and chug stuff. That's fun though. I mean, it's fun to know you can do both. That's really cool. Let's see if we were right or wrong though. Because sometimes I make dumb mistakes like a minus sign or a plus sign. 64? Is that what we got for our slope? 5? 64t. I would have put x and it would have said nope. And then you would have. What? It says use the variable they give you. 12. 773? 12 hours. Sweet. All right. Tomorrow we're going to do something a little different. Tomorrow we will not be